Welcome to the Forest Analytics Landing Podcast. I'm your host, Matt Russell. In this podcast, we'll talk about how data and analytics are transforming the forest products industry. Hi, everyone. This podcast is going to be talking about harvested wood products and the importance of understanding carbon sequestration when it comes to the value that forest products play in the forest carbon cycle. And so I'll include a link to this in the notes, but this was a presentation I recently gave at the New England Society of American Foresters meeting. This happened back in March of 2023. And so I'll kind of highlight a couple of things. First of all, the importance of harvested wood products, and then I'll talk a little bit about how we define and how we quantify the carbon in harvested wood products. And then I will talk about a case study that I used when I looked at harvested wood products coming from a long-term experimental forest. And so I'll chat about how I use the forest vegetation simulator as a tool to understand harvested wood products output. And so to start, harvested wood products are an incredibly important source of the carbon that we count in forests. And so foresters and loggers, they often deal with carbon in live trees, but trees are not the only component where carbon is stored. First of all, in the forest, not just live trees, but also the stem, branches, and roots. Carbon is also found in pools such as deadwood that can include standing dead trees and coarse woody debris, litter, and soil. And then the carbon after timber harvest occurs can be stored in harvested wood products. And so all the time, harvested wood products are not always counted in our estimates of forest carbon. One thing is that it's really difficult to quantify, and so I can understand why lots of people overlook those. But we need to incorporate the harvested wood products in all of our forest carbon assessments to get a better, clearer depiction of the forest carbon that we're dealing with. And so there's obviously a lot of value in counting harvested wood products. When you think about mass timber, when you think about tall wooden buildings built with wood, it tells a good story that we're using wood as a sustainable resource, and that carbon is going to be stored in that building for decades, even centuries later. And so when you compare wood and other ways to build buildings, like with concrete and steel, there are a lot of benefits using wood compared to those other greenhouse gas intensive materials. And so when we look at, in the United States anyway, the harvested wood products store a tremendous amount of carbon across the country. If you look at all the forest carbon stocks, that's everything found within the forest from those pools I mentioned, from above ground live trees, dead trees, litter, and soil, the harvested wood products account for almost 5% of all of the forest carbon stocks. And so by not including them, we're not really capturing a lot of the carbon that's out there in the country, in this case of the United States. So when we look at harvested wood products, we can think about them categorized into two different areas. The first one is products in use. So those are things like your kitchen table, things that are storing carbon for the long term, being used by society. And then we have solid waste disposal sites, and this is the place where typically the harvested wood goes to decompose in these landfills in particular. And so if you look at the trends, using some data from the USDA Forest Service, the trends in harvested wood products and in the solid waste disposal sites have increased pretty steadily since 1990. If we look all the way back to 1990, these pools in harvested wood products stored about 1,500 million metric tons and almost 1,200 million metric tons in solid waste disposal sites. But if we compare that to what they are today, they've increased 23% and 81% since 1990. And so that's an incredible increase in terms of the amount of carbon that's being stored in harvested wood products and in solid waste disposal sites. There's lots of ways to calculate how we derive harvested wood products. The best resource for this, and this is really focused on the United States and how they quantify forests, but an excellent paper in 2006 by Jim Smith and colleagues that looked at how to calculate forest ecosystem carbon and the harvested wood products based on forest inventory and analysis data, the National Forest Inventory of the United States, and how that relates to different regions and different forest types within those regions. And so that paper is very highly cited. It's a general technical report from the USDA Forest Service. What others have done is they've used the methods in that report to then use in a lot of simulation models. And so if we do things like integrate forest management into our estimates of forest carbon and harvested wood products, we can use the ratios and the conversion factors that are found in this report by Smith and others to understand what the fate of harvested wood is. And so as one example, the forest vegetation simulator uses these equations and these tables that are found in the Smith report as a part of its fire and fuels extension. So the FVS model is a forest growth and yield model that reports the fate of trees as they go on and grow up. And one of the reasons people use it now increasingly is carbon. And so FVS provides a number of carbon outputs into its system. When we look at the harvested wood products pools, what FVS does is it separates between two merchantability classes, so pulpwood or saw timber. And then it separates things into 4 different categories. And so those 2 categories I mentioned, the harvested wood products that are in use, and then the harvested wood products that are in the landfill or the solid waste disposal sites. And then it also tracks the emissions, and so it counts the emissions that are associated with energy capture and the emissions without energy capture. And so you have these 4 different pools if you pull the harvested wood products report from the FVS tool. And so it's a really handy way to look at the fate of harvested wood through time. And so I was interested to see how well this the tool would do. I've used the harvested wood products reports quite a bit. But one thing that I wanted to do was going back to this point that, if we do any type of silviculture, any type of forest management, are we really capturing the full benefits and all of the carbon sequestration that's going on? And so what I wanted to do was to pull some data from an experimental forest not far from me. This is the Penobscot Experimental Forest located in central Maine, and to simulate the data from that forest into FVS and to track the harvested wood products that result from it. And so I think a lot of great things can be made, comparisons can be made, looking at different carbon sequestration rates when we include the harvested wood products and when we don't. And so for this short little case study I used with the Penobscot Forest, I used 2 different treatments. And so on that forest, I have a selection treatment that operates at a 20-year cycle. And so this selection treatment is an uneven aged way to manage forests. It uses both single tree and group selection, harvested every 20 years. And then the other one I chose was a more exploitive measure of the silviculture that's not used widely, but just for comparisons, I chose a fixed diameter limit cut. And so this is basically a thin from above, where all the trees are removed that are greater than 8 inches in size. And so I kind of simulated the harvest for those in FVS using this data from the Penobscot Forest. And so I kind of took the data and put it in for 100 years to look, from today until 100 years from now. With the fixed diameter limit cut, it was basically one harvest. And so it was harvested just once and then grew back after that. With the selection cut, obviously that operates on a 20-year selection, so there were 5 harvests across that 100-year span. And what you can obviously tell is that the carbon obviously tracks pretty well with those harvests. So as those harvests are removed, as those harvests remove wood, the total carbon goes down and then immediately kind of goes back up after those stands begin to regrow. And so here's the interesting part. And so I was interested to see, what if you just looked in the woods? That is, if you looked at what a lot of people quantify as just looking at the carbon stocks in the woods. And so what you see there is that obviously anything before harvest is just growing. And then immediately after harvest, you see all of these carbon stocks go away. And so obviously those are going away to harvested wood products pools, to slash that, it's pretty rare that every single pound of carbon is going to be used from a timber harvest. There's going to be residuals and slash and things like that. And so what I did in comparing the two approaches was just look at in the woods. And so in this case, doing that approach for the different, in this case, this is one of the fixed diameter limit stands. If you look at just what's happening in the woods and look at the carbon sequestration rate, you get a 0.497 tons of CO2 equivalent per acre per year that is sequestered. And so that's just kind of looking at in the woods. And what we typically will quantify, if someone said that's the uptake rate or that's the sequestration rate, that would be, everyone would say, okay, that's a good number. But if we include the harvested wood products, we actually see a higher sequestration rate because we're including all of that harvested wood in our calculations of carbon sequestration. Now, once it's a harvested piece of wood, it's not going to really sequester carbon more. All you're doing is you're not letting that piece of wood decay or decompose through time. Now, obviously it does, but you're actually adding more stocks at each time. And if you look at the tool like the Forest Vegetation Simulator, all of these harvested wood products decay over time, but they have stocks associated with them. And so you're adding those stocks to the same stocks that are in the woods. And so if we do that, if we include both in the woods plus the harvested wood products, we get an average annual sequestration rate for the Penobscot Forest of 0.579 tons of carbon dioxide equivalent per acre per year. So you can compare that to the 0.497 number, and it's a large difference. And so oftentimes, as I mentioned, we only are accounting for the carbon sequestration that's happening in the woods. But if we encapsulate what's happening in the harvested wood product pool, we can get a better representation of all of the sequestration that's happening. And obviously it's higher, the sequestration rate is going to be higher if you incorporate the harvested wood products versus if you don't, because those pools and harvested wood amount to quite a bit. And so I really encourage you to have a look at, if you're using a simulation model that incorporates harvested wood products, have a look and see what the output is in some of those reports. The harvested carbon report is a great one from FVS that pretty much provides all of these values throughout the simulation that you choose. And then you're able to kind of take those values and add them, like I've done, to the in-woods carbon values to get a sense of the true value of carbon sequestration that's happening in your forest. Tools like the FES tool, they have different ways to calculate carbon. Different biomass equations are available depending on which equations you're more comfortable with, which equations you're more familiar with. So there's lots to choose from there. And then the important thing, a great tool like a good growth and yield simulator, is you're able to change some of the merchantability limits. And so as an example now, if you look at some of the FVS harvested wood products report, the default limitation or the threshold for pulpwood is anything less than 9 inches for softwood, anything less than 11 inches in diameter for hardwood. And so some big differences there. If you wanted to change those, if you have different merchantability specifications, you can do that as well. So encourage you all to have a look and to think about harvested wood products as you're thinking more broadly about forest carbon, because I think they're going to play a bigger role if we really want to capture the true value of carbon sequestration in our forests. Thanks for listening to the